In this video, we'll continue to practice the quotient rule of exponents. Remember, the quotient rule of exponents tells us when we are dividing things with the same base, we can just subtract our exponents to get our new exponent. So in this video, we are going to work on problems that have more than one base. So for example, our first problem is x to the fourth, y to the third, over x, y to the second. So the most important thing to remember is you can only deal with bases that match. X's with x's, y's with y's. You cannot worry about subtracting exponents from the bases that do not match. So I could not subtract a y base from an x base. They have to match. So we can think of this problem as two different problems. So first, let's try this as if we were just writing it out without using our quotient rule. So if we wanted to write this all out, it would look like this. So x to the fourth would be 4x's times y to the third. So we've got 3y's going across. That's our numerator. The denominator is 1x, and then times y times y. So remember, we can cross out things that match up from the top to the bottom of our fraction, because when we divide something by itself, it equals 1, so it goes away, it cancels out. So I find pairs. So here's a pair of x's. There are no more x's I can cross out because there is only one x on the bottom, so only one x on the top can disappear. For the y's, here's a pair, and here's a pair. There's no more that I can cross out. So I am left with 3 x's and 1 y, which would make my answer x to the third y. Now we can go back and use our quotient rule. So we want to, again, think of these as two problems. So first I'm going to deal with my x's. Using my quotient rule, I know that I can just subtract my exponents. The problem is here, this x on the bottom doesn't have an exponent written with it. When there is no exponent written, it is 1. You can write it there if that helps you remember. 1. It's not 0, it is 1. If it was 0, we would see 0 written there. So the math problem I need to do is 4 minus 1, which gets me 3. So my new exponent for x is x to the third. And then I can do the second part of my problem, the y's. I've got y to the third over y to the second. So my exponent rule tells me I need to subtract 3 minus 2, which gets me 1. And like we just talked about, I don't have to write 1 as my exponent, so I can just write y. X to the third y matches what we got when we just drew it out and crossed off. So let's practice the other two ones strictly using our exponent rule. But remember, we can think of them as separate problems. We just write our answer together. So if I look at this example here, x to the sixth, y to the fifth, over x to the fourth, y to the second. First, I'm going to worry about my x's. So x to the sixth over x to the fourth, my quotient rule tells me I should just subtract 6 minus 4, which gets me 2. So I know my new exponent for y is going to be 2. Now I'll switch over and worry about my y's. This problem is y to the fifth over y to the second. My quotient rule tells me to subtract my exponents. So I need to do 5 minus 2, which gets me 3. So my new exponent for y is 3. So my final answer is x to the second, y to the third. For our last example, a to the third, b to the ninth, over a to the second, b to the third. First part I'm going to look at are my a's. My exponent rule tells me I should subtract my quotient rule tells me I should subtract my exponents. So 3 minus 2 gets me 1. I know I don't need to write 1 as my exponent, so I'm just going to leave a as it is. Now I'll worry about the second part of my equation here, the b's. B to the 9th over b to the 3rd. I'm going to use my quotient rule. That tells me to subtract my exponents. 9 minus 3 gets me 6. So the b stays there, and the new exponent is 6. So my final answer is a, b to the 6th.